Okay, welcome back. In the last video, we just added running animations and jumping animations. So between the videos, I just went to the animator, went into the movement, and just sped up my running animation by another 50%. Just felt a little bit slow. I could slow the character speed down, but I just thought it would be funnier to just make the animation run faster. Just so it looks like the feet are planted when it's running. So that's what we did. So all we want to do now is essentially set up a camera animation. So I'm just going to duplicate this camera. So I'm going to call this camera bolt. I'm going to duplicate that one more time and call this one camera code. I'm going to hide the camera code for now because we're going to use one camera at a time. And then I'm going to kind of reposition my camera to where I think it needs to be. It feels a little bit far away at the moment. So yeah, let's make it 2.5 by -7. Let's see. Now that doesn't look bad. I'm going to change my aspect ratio to 16:9 so I get a sense of what it's supposed to look like once we're in the actual 16:9 resolution. That is my camera. Okay, so let's add a new component to the camera, which is going to be a flow machine. And we need to add a new script, so I'm going to click on the script. I'm going to go to scripts. I'm going to call this camera controller bolt. You don't have to call it bolt, I just call it because I'm using both bolt and codon. Even though they don't conflict with each other, I just never like to have the same thing named, two things named the same. So I'm going to hit edit graph, open up the graph here, and let me just maximize this and we're going to be doing everything in the update for the camera. And what do we need to do? We need to essentially go transform.position set. We're setting the camera's position, and we're going to add about 3 object variables. The first one is going to be making a reference to the player, so let's call this player reference. It needs to know where the player is. Well done with the spelling. Let's try that again. Jeepers. That's better. And this is going to be referencing a transform, because all I want is all the transform data from the player. And all I can do is click on the side here and choose from the list in the scene. I'm going to look for player bolt, because that's the one that this one's going to follow. I'm going to drag this in, and let me just show you what happens if you just directly plug this in. So we're going to go here and we'll type in transform.position and plug the position of the player to the position of the camera, the position of the camera to the position of the player. Let's see what happens. Here's the camera. If I push play, the camera is no longer in the right place. The reason for that is if I go into the scene view while it's paused and select the camera is now moved all the way to the player's feet, where the player's origin or pivot is. So it's doing exactly what you're telling it to do. It's saying grab the camera and put it where the player is. So we need to allow for an offset value to happen. So we can offset that camera. So in the object variables, and this is going to be a variable I want people to be able to adjust. So we're going to call this camera offset. It's going to be a vector 3. And I think we set it to be 2.5 and -7 as it stands. So I'm going to put that values. I'll show you where I got those values from. We're going to drag that in. And we're just going to drag from the player position and go add. And we're just going to add this offset. Remember to choose add a vector 3 because we're doing vector 3 with vector 3. And we're going to plug the add into the actual position. Now, if we go back here and I go to my variables, 0, 2.5, -7, that is where the camera currently is, 2.5 -7. So when I push play now, it's going to be using that offset value. So now my camera is following my character using the offset value. So if I go and adjust this offset value in the editor like that, notice how the camera still follows, but it's using that offset value. So that is how we're going to allow for the camera. And what's nice about this is you can adjust it at runtime to see the values that you like, and then just record those values and then put them back in once you stop playing the game. So I think 2.5 and -7 is good for now. I'm going to test it one more time. That's not bad. I want to move the camera a little bit lower, but I think overall that's not bad. Now the thing is, this is very hard. There's no, let's say, interpolating or smoothing. The camera doesn't have any kind of lag. What if you want to add lag to your camera? So that's where we add our third variable called, let's just call it camera move speed or movement speed. Let's do that. So camera movement speed, that's going to be a float, and this, I'm going to set the default value to be, let's say, 1 for now. This is going to be how fast the camera is going to catch up with the player. So we're going to drag that variable in, and we're going to add one more. Now you can use a lerp, you could use like a vector3.lerp and use this, but I like to use a built-in function in Unity. So if you drag off from the transform.position on the left side and type in move towards, you're looking for the vector3 move towards, and we're going to, so what this does is it says I'm moving from this position to that position over this amount of time. That's what that does. So the position we want to move to is the camera. And where do we want to move from? I'm just going to duplicate this transform.position get and just plug that directly into the current. So this is the current camera position. This is where it needs to go. And this is the speed at which it goes. So let's just plug this directly in and see what happens. So notice how it's going, and if I tweak the speed value while we're in the game engine, doesn't feel, do you see how it is a little bit lag? Like you can feel that it's working, but you're going to have to go into really tiny values like 0.01. Notice how the camera slowly catches it, creeping up. So it's working, but I don't like to work with such small, tiny little values. So what I tend to do with my camera movement speed is I like to multiply this value and plug that back into the max delta speed. And the B is going to be time.delta time. Just so that I can make these values a little bit like a little more forgiving, because it's quite tiny. I don't want to go into such small values. So we're just going to put comments around this so we know what's happening here. So this is current camera position. That's what that is. We'll just move this down a little bit. This next one is player position. Our player position with offset. We really should say that. With camera offset, and then the last one here is essentially the camera movement speed, just so that we kind of know what each of these things do, and then the whole thing can be put into a camera follow player. Let's just actually tell it what it follows. So you never know. You never know. It could be following something completely different. Okay, so I'm just going to neaten up my workspace a little bit so it looks a little bit better. Okay, so that should do it. Now the values don't have to be, so 1 is now going to be quite a slow value because we're multiplying it by time.delta time. So as I run, notice I have to wait for the camera to catch up. When I jump, the camera doesn't even have time to get to the top before it gets to the bottom. So I'm going to make the camera movement speed about 5. Probably needs to be a little bit faster, but that's not bad. Yeah, so we'll leave it at 5 for now. Actually, let's just make it about 7.5. And that's how you make a camera follow character with an offset. All we did, we created all of this with 3 variables, one for the reference where the player is, the other one a reference for where the camera should be in relation to the player, and then the last one just the speed at which we're going to blend between the camera's current position to the new position that it should be at. Again, neating this up. Sorry. just a problem I have. Okay, so now that's it for the Bolt. Let's do the exact same thing for the C#. So now I'm going to hide the Bolt camera, unhide the code camera, and I'm going to create a new script. It's going to be camera controller. Let's make it C#. There we go. And I'm just going to assign that once it's recompiled. It's giving me an error. That's really beautiful. I'm going to double check why that error is. It's probably, it's because of the C# thing. So let's just call it code. So I'm going to rename that, and you can't simply just rename it here. You need to go also and rename the actual file so that the two kind of work together again. And now I can go and assign that to the physical camera. There we go. Just grab the camera code. There we go. And now we can go back to Visual Studio Code. And remember, we're only using the update, so I'm going to remove the start. And I'm going to create a variable which is going to be a serialized field, and that is making a reference to the player. So we're going to use a transform. We'll just call this player reference. Keep all the variables the same names, both in Bolt, so you can always refer back. I'm going to create the next variable that we're using, which is a vector3, and that's going to be the camera offset. And then the last one is going to be a serialized field again as well, and it's going to be a float, and this is going to be the camera movement speed, which I think by default will set to 7.5, noticing that it kind of feels like that should work. Remember, you need to put an F, you've got a point, that's why it's giving me an error for float. I think that's all we need. So in the update, okay, so I'm just going to put some comments here. So this one here is a reference to the player in the scene. And this one here is going to be a offset for camera in relation to the player. Okay, and then the last one is the speed at which the camera will move to the player. There we go. I just kind of like to do comments just to remind, like I always kind of say there's like 3 versions of you. There's the past you, present you, and the future you. And trust me, the present you always hates the past you for doing lazy work or forgetting to do something, because you have to kind of figure it out. And future you will do the same thing if you don't consider the future version of you, who has to maybe come back to this code in a couple of months and say, I have no idea what the hell is happening here. So it's always just kind of better to give yourself a few pointers or notes. So I'm going to put a comment here, say camera follow code. Okay, so over here, all we're going to say is transform.position, like we did in Bolt, is equal to, and what is it equal to? It's going to be equal to the player position, so player ref.position, plus, remember we added the camera offset, that's not the camera offset, so we got the camera offset, and then we essentially took the, actually let's just leave it like this so you can see that it's going to work. Okay, let me just show you what we're going to do here and kind of talk you through it so that makes some sense. Okay, so you'll see you have 3 new variables. We need a reference to the player, so we're going to select this, go to scene and type in player and look for the player C#. And the offset of the camera is the same. It's actually, no, it should be the same as the other one. So 2.5 and minus 7.5, I think, is what we used. So I'm going to say 2.5 and minus 7.5. Okay, so let's test to see if this works. The camera will now follow without any eloping or interpolating. There we go, it is working. And again, if you move these values, you will be able to adjust it and see what it looks like when you're playing with it. So in the graph, remember what we did? Let's just see, we have essentially done this section of the code here. Sorry, this section of the code here. So we need to do a move towards, and then from that use the move towards to drive that value and this value by that speed over there. So we need to do a move towards before we actually do all of this. So let's go back to our code, and before we do all of this, I'm going to do this. I'm going to type in vector3.move towards, because remember we're using a vector3, and if you hover over the red, it should normally give you a solution to the problem. It normally says, okay, cool, by the way, you need 2 round brackets, you need the current position, the target position, and the speed at which it's going to move. So we know we need to get the current position, and we need to get the player dot position multiplied. I add the camera offset. That is the next position, and then what do we need to do it? We need to multiply that by our camera movement speed, and then multiply the camera movement speed by time dot delta time, just so we get a reasonable number to work with. Okay, so the exact same thing. So we're using a move towards, we're saying get the current position, move to the player's position, plus the camera offset. And at what speed are we moving? We're using the camera movement speed multiplied by time dot delta time. Okay, so let's test that now, and now both cameras will work. They can't work simultaneously. You can really only have one active camera at a time. There we go. I like using the move towards as well because you get less jittering or kind of really weird feedback updates when you're using this, as opposed to using a lerp. The lerp you can get really smooth results, but a move towards it's designed to do what it says. It takes moves an object from one location to another. This is a really powerful tool to use for lifts, platforms, objects that like kind of create these crunching like where as you walk near it, it'll drop down towards your head. You can do a lot of these cool things without having to even touch physics. You can just use a move towards. And that's it for this video. So hopefully it's been helpful. And next week we'll just progress forward and just adjust these controllers and then move on to doing other systems and other mechanics. Till I see you next time, be safe and thank you for watching.